Hello, welcome to my channel. We will be doing question number 11 today. Okay, so what is this question? We are given that a particle is moving on the x-axis, along x-axis. Okay, so its displacement from origin, from point O, at any given time is given by these expressions. Okay, so for first 3 seconds, it will follow this expression, and after that, it will follow this one. Okay, so okay, in part A, we are told that we have to find the velocity time graph. We need to make a velocity time graph. Okay, so knowing the distance or displacement, we need to find the velocity first. So how can we find the velocity? By differentiating the displacement. So the derivative of this is going to be 1 plus 12t minus 3t squared. This is when t is between 0 and 3. And it is equal to 12 minus 2 by 3t when t is between 3 and k. Okay, so this is the speed, or yeah, this is the speed versus time. And we need to sketch this graph over here. Okay, so let's make a quick table. This is time and this is speed. When time is 0, we'll use the first expression and it will give me 1. When time is 2, it will give me 1 plus 24 minus 2 times 2, 2 so 4 is 12. So, am I right or no? 1 plus I'm doing some mistake, I looks. Okay, that is 12. That's not 13. Okay, sorry, I have to do it 1. I'm sorry. Okay, when t is 1, then it is 1 plus 12 minus 3. So it's still going to be 10. Similarly, when at 2, it is going to be, yes, this is 13. And at 3, it is going to be 1 plus 36 minus 27. So this is 137 minus is going to be 10 again. Okay. After 10, we have to follow this expression. And this is like, this looks like a straight line because there is no square in t. So at 3, it is giving us 10. Yes, it is the same thing. But after that, let me write something like at 6. Okay. When time is 6, it is 8. Okay. In the same way, when it is 9, it is going to be 9. So 3 to 6 and so on. Okay, so now we are ready to make a sketch. So when time is 0, it is 1. When time is 2, sorry, but time is 1. Why do I mistake again and again? Okay, when at 1 it is 10. So let me say 10 is here. Okay, and this is not perfectly to the scale. Okay, when time is 2, it was 13. So it is somewhere here. When time is 3, it is again 10. So somewhere here. Okay, and after that it's a straight line. So first of all, it is going to be something like this. No, I'm not very good at making sketch like this, but it is something like this. Okay, I hope you agree. It's a parabolic thing up till here. And after that, it's going to be straight line, something like this. Because at 6, it is 8 only. So this point is 8, right? And so on. So at, for example, k, the velocity is going to be 12 minus 2k by 3. This is the value of the velocity. or let me write it here. This value is going to be 12 minus 2k over 3. So this is my velocity time curve using this expression. Okay, so this was easy. Now let's go to this next part. The total distance traveled um, from 0 to k is 57. Okay, so we are told that up to t, the distance and displacement are same. Okay, we just calculated that at t, when t is equal to 3, the distance or displacement, it was, we just found it as, I believe it was 30. Uh, oh, I think we didn't find it. Yes, yes, we didn't find it, but we can find it. You see, if I use the first expression, this expression, and t is 3, it is 3 plus is 54, right? Minus 27. Yes, so it is 27 plus it is 30, right? Or if I use this expression, we can use both of them because at 3 they are same. They should be same. So this is 36 minus t is 3, the 9 over 3 is 3, and minus 3, it is again 30. Yes, so at 3, uh, when time is 3, the displacement or distance is 30. Okay, and we are told that when time is k, the distance is 57, right? The total distance traveled by p is 57 meter. Okay, so can I write it this way, that the distance at k, right? Distance at k, this is equal to distance at 3 plus, remember, if I have velocity time curve, right, then the total distance traveled is equal to, or displacement, in this case they are both same, is the area under the curve. So I have to integrate v dt from whatever point to whatever point I want to find the total distance from A to B, for example, right? Okay, so in this particular case, now I have to integrate the velocity expression, which is 12 minus 2 by 3t, okay, from 3 to k dt, and this must be equal to 57. Okay, this is the most important step in this problem. So I hope you understand every element over here. Okay, now distance at 3, we have found it at as 30. Okay, so 30 plus, now let me integrate this is expression. So it's going to be 12t minus 2 by 3, and this is going to be t squared by 2. It had as limits of 3 to k equal to 57. Okay, I hope this is clear to everybody. Now, what I will do, I put the upper limit. So it's going to be, I will take 30 on the other side. So on the right side, I have 57 minus 30. And on the left side, when I put the upper limit, it's going to be 12k minus 1 by 3 k square. This is the upper limit. And when I put the lower limit, it's going to be 12 3s are 36 minus 1 by 3. Okay, 2 cancels with 2. So 1 by 3, and 3 square is 9. Okay, so this is going to be 33. Am I right? Okay, so 33 negative will become plus 33 here. And already I have 27 here, right? 57 minus 30 is 27. On the left side, I have minus 1 by 3 k square plus 12k. Okay, so this is going to be 60. Yes, this is 60. And I have minus 1 by 3 k square plus 12k. Now let's multiply everything by 3 or minus 3. So it will become k square and the minus 36 and it, if I bring it on the left side, it will become minus. So it is minus, and then it will become plus 180. This is 36k equal to 0. Okay, is it correct? I hope you understand. This is okay. Now I can make factors of this thing. For 180, I can make factors like 30 and 6, right? Yeah, if I multiply them together, it's this. Okay, both have to be negative. Okay, so it's k square minus 30k minus 6k plus 180 equal to 0. So when I take k common from here and minus 6 from there, and here I will have k minus 30. You can check if I multiply them together, it is going to be minus minus plus 30, 80, 180, yes. And yes, this is correct. So this gives me k equal to 6 or 30. Okay, these are the two values of k we get from this solution. Okay, but look at this thing. Remember, we were told that, yes, in this region, 3 to k, the velocity is positive. Okay, velocity is positive. Now we know that velocity was given by this expression. 3 to k, the velocity was given by this expression. Okay, in this expression, 12 minus 2 by 3k, when I put k equal to 6, okay, it is a positive number. But if I put k equal to 30, right, the other solution, if I put k equal to 30 here, then it's going to be a negative solution. So that's why we will discard this value of k, and my final answer is k equal to 6. Okay, I hope this question makes sense to you. It was a bit challenging. You have to think about it before solving. Anyway, if you have any question, you can always ask me in the comment section. Thank you very much. Thank you for watching. I will see you in the next video.